Welcome to Advanced Maths. Today we are going to solve this particular problem from class 12, exercise number 7.3 and question number 13, and this was asked by one of my viewer to solve this problem. Now let us see how can we solve this problem. To solve this problem we will use one formula that we have studied in class 11. That formula is that cos x minus cos y equal minus 2 sin x plus y by 2 sin x minus y by 2. We will use this formula to simplify this given function. Now we have to find the integral of this function. So before finding the integral, let us simplify the given function by using this formula. Now in the numerator, let us apply this formula by taking x as twice x and y as twice alpha. That means minus 2 sin twice x plus twice alpha by 2 sin twice x minus twice alpha by 2. In the denominator, this is minus 2 sin x minus alpha by 2 and sin x plus alpha by 2. After applying this formula, let us simplify more in the numerator. That means, and we can cancel this also. That is sin. If we take 2 common here and we can cancel this with this one, then we are left x plus alpha sin x minus alpha divided by sin x minus alpha by 2 and sin x plus alpha by 2. And here by mistake I write minus first, but no problem here because both are sin. If one is sin and one is cos, then you must careful about this plus and a minus. That means we in the formula I write plus first, but when I apply here I write negative first. So no problem here for this question because these both are sin. So now let us use another formula that we studied in class 11. That formula is that sin x is twice sin x by 2 and cos x by 2, and let us apply this formula to these two functions separately. This one, that is sin x minus alpha by 2 sin x plus alpha by 2. And let us first apply in this first, that is we will take x plus alpha as x, then this will be twice sin x plus alpha by 2 then cos x plus alpha by 2. Next, in second formula, that is twice sin x minus alpha by 2 cos x minus alpha by 2. Now let us cancel the common terms from numerator and denominator. That are, we can cancel this one with this one and this sign with this sign. Now we are left 2 and this 2 times, that means 4, and cos x plus alpha by 2 and cos x minus alpha by 2. Here the given function, the simplified form of this function are now in the product of cos with different angles. Now we will again apply this we will again apply some other formula which can be expressed this given function in terms of sum of two functions. That means there is one formula that is twice cos x and cos y. We can express this formula in terms of sum, and if we can express the given function in terms of sum, then we can take integration separately. But in product we have to apply integration by parts, but that will be more difficult here. So let us try to convert this into some form. So to convert this, we have to apply this formula. That is, we will use this formula, this twice cos x cos y equal to cos x plus y plus cos x minus y. Now here we write this for s2, and the another 2 is 2 cos x cos y. We will express in this form. After expressing that in this form, we will take this x as this one and this y as this one. Now let us apply this formula such that cos this is x plus y. X plus y means x plus alpha by 2 plus x minus alpha by 2. Next, plus cos x minus y, x plus alpha by 2 minus x minus alpha by x minus alpha by 2. After applying this, let us simplify again. That is 2. Now we are left cos this. If we take LCM 2, then we in numerator the alpha is cancelled, then we are left twice x, and twice x by x, this is only x plus cos. Here again, if we take 2 LCM, then we x will be cancelled. After that we are left twice alpha in the numerator, and the twice alpha 2 cancel with the denominator 2, then we are left cos alpha. Now the given function is expressed as twice cos x plus twice cos alpha. Now we have simplified the given function as like this. Now let us try to find the integration of the given function, that is equal to, and we have simplified this function into this function. So let us substitute instead of this one, that is twice cos x plus twice cos alpha all dx. Now these two functions are in terms of sum, so we can separately take the integration for both of the function. That is, for first we can take integration to cos x and then plus 2, then here both are constant. Here there is no value of x here, so we will take this as a constant. So let us take this outside the integral, then dx. Now the integration of cos x is sin x, so this is twice sin x, and here this integration of dx is x, so this is twice x cos alpha, and this is the constant of integration. This is how we can solve this particular question. Thank you.